Greetings of the day. This is Shruti Sharma of class 10E presenting the research about the mathematics behind the architecture of Taj Mahal. Introduction to the beautiful Indian memorial. The Taj Mahal, finest and most sophisticated example of Mughal architecture whose origins lie in the moving circumstances of its commission and culture and history of an Islamic Mughal empire's rule. The Mughal Emperor Shah Jahan commissioned the tomb upon the death of his favorite Mumtaz Mahal. Now, going on to the mathematics behind the Taj Mahal. The geometry used in its making is frequent in all the geometry classes. Architects could use the principles of the Taj to create a similar building. The Taj Mahal was created using maths beyond its time, particularly geometry. Symmetry in the making of the Taj Mahal. The symmetry of the building is yet another aspect worth mentioning. Equal distance of windows and doors from one another, formation of minarets, proportion of domes to the archways. Talking about the area and volume of the monument, one can calculate them for half of the building and double it only to find the exactly correct answer. The Taj has a symmetry on both inside and the outside. The mausoleum and its associated structures were designed around the principles of reflection and repetition. The tomb itself is essentially a cube with chamfered corners to give it an octagonal cross-section. The four sides are identical, each one featuring a huge vaulted archway. Four minarets frame the tomb. Reflection symmetry is also found in the decorations, made from precious and semi-precious stones inlaid on white, translucent marbles. Geometry in the making of the monument. While the walls and outer surfaces of the tombs are adorable, but it's also worth looking down at the intriguing tiling patterns of the paving stones that cover the ground around the Taj Mahal. Next to the tomb, the stones lie in a distinctive pattern of four-pointed stars made of red sandstone and diamonds as shape made of marble. Reflection symmetry is characterized the pattern of paving stones surrounding the Taj Mahal. Even the drainage holes in some of the holes have a strikingly hexagonal pattern. In a number of other locations, the tiling pattern of the floor consists of regular hexagons with six-pointed stars. Also, amid the symmetrical gardens in front of the Taj Mahal, walkway stones are laid in a pattern that combines squares and elongated hexagons to create regular octagons. Finally, moving on to trigonometry in the making of Taj Mahal. The opposite of the theta, that is angle CAB, BC stands for the perpendicular of the Taj Mahal with respect to the ground to the finial, the tip of the dome. The adjacent of the theta, AB, is the distance from the center of the Taj to any person standing 100 feet away. Theta is equal to 79.9 is the degree of elevation the person looks up to see the top of the structure of the Taj.